So we are at the National Guard Railway Convention here in Tennessee, and we have Jonathan who's going to explain to us his system, his Scaled Automation system, and that is your company, Scaled Automation?
That's correct. And so it's been in business a couple of years and developing a product that we know is revolutionary, completely different way of controlling model trains.
And what is your system called?
We're calling it PROSys to give it a name. It's just a name to try to say that it's as close to the prototype as we can, and it's a real fully integrated system.
Okay, good. Could you show us how to use it, or what it's...
We can. And so the system itself for running the locomotives actually relies on a full-scale simulation on the cab control. And so it's radio operated. It can be run on live rail, but this particular one is dead rail running off a battery. And it runs over what's called XB for radios. It's a very high quality, very good system for radios. We have a Bluetooth version available as well, but the XB has longer range, it has more security, so that's what we're using. What's different on our system is that we're actually modeling the cab control of a real train. And so to start the train, you literally push an on button. And that starts it up. The engine just started. It's kind of hard to hear in the hall because of the noise. And then to operate it, we go to the other screen where the operating system is, and we're going to actually put it into forward, and we're going to give it throttle. So you'll notice we're doing a reverser, a throttle, a dynamic brake, and a full automatic air brake system. There is a place down here for the engine independent brake, but the screen doesn't show it. And so as we give it throttle, it's actually going to start to move, and then it has the full 8 steps. And because the train we're modeling is very lightweight, it got up to speed very quickly. So we'll pull it back to idle because otherwise it'll keep speeding up. So when I said the train that we're modeling, one of the things that's on this screen, this is where we get to actually choose the train that we're modeling. And right now we're modeling what we see here, which is an NW2 pulling one boxcar, and right now no tonnage on it, and it has a caboose. But we can change the engine type. This happens to be a GP38. We can add different cars in the amounts. So for example, if we want to change this to 10, we're going to add 10, and you can see a 10 right here. We're going to put some weight in it. I'm just choosing 80 tons. Oops, we got a 0 there. And then all we do is hit the program data, and that just sent the data for that train to the locomotive. Now it didn't do any change that you saw because we're already running. So let's slow it down a little bit. We'll apply some brakes, watching the speed. We'll pull it down to about 10. Now it's slowing down pretty slow because it's got a big train behind it now. So let's pull it back to 0. And now as we go to position 8, you'll see that the train itself speeds up much slower because now we're pulling a big heavy train with a fairly small engine because an NW2's only got 1,000 horsepower. And of course it has the full sound effects. The bell is very quiet on this particular board. So again, what's different is that we're actually modeling a train and its loading characteristics and the weight it has. It does have a glitch there.
Oh, wow.
Let's speed it up and get it over that glitch. So instead of just turning a single knob, you actually have to operate a train throttle, train brakes, you have to operate the reverser, just as the full scale.
Wow, that's pretty neat.
So that's pretty much the highlight of it. And if you have any questions, of course, we have a website, scaledautomation.com. Find out more information about how we're doing this.
Okay, and how about the system itself? Is it like plug and play with USA Trains, Aristocraft, or?
Yeah, this is a USA Trains, and to make the system operate, it needs to know exactly how fast the motor's turning. So there's a sensor on there. So the motor itself has to be modified for that sensor. That sensor then brings back the data to us to display on the display. And it also uses that sensor to keep the RPM exactly where it wants. So the train has calculated how fast it ought to go, how slow it ought to go, but then it uses that feedback from that sensor to set the motor to exactly the right speed. So modifying the train for that sensor can be a challenge because we got to put a sensor on there. In O gauge, it's actually a lot more common to have that sensor already mounted.
Yes.
So, but in G scale, I haven't seen them. We've been able to modify this particular motor block for that. We have a board available that lets you do that. So, and then that sensor on the shaft then is used for feedback to keep the speed exactly constant.
Okay.
And if you want to step over here, I can show you the boards. I have a display to show you the boards.
Sure. Let's head on over this.
So our main controller board is this one, and this little tiny chip right there is amazing because that's a 32-bit processor doing all those calculations. It runs the real-time calculations 20 times a second to calculate how fast the train ought to go. The external boards for communication is either a Bluetooth board or an XB. It'll run either one. I don't have a sample, but this would be the shaft encoder board, and then anybody's soundboard that runs off a DCC. The system actually computes DCC signals, has an interface, and then drives that sound card. So you can use any sound card you want. We're using a Lock Sound right now. They have a new one called the Lock Sound 5 FX that is a perfect match for this. One of the things that's very different, there's an onboard motor driver for 10 amps, that's kind of normal, but there's also an external motor driver. This motor driver is good for 40 amps.
Wow.
So there is no locomotive out there in G scale that this won't drive. And this could be anybody's motor driver. So you can get ones that are hundreds of amps. This could drive the 7-inch scale and those guys. It could even drive their locomotives.
That's pretty powerful for a chip.
It is. It's amazing technology. And of course, I then go and select the ones that are good. This is an off-the-shelf product, $30. So yeah, it's $30, but you can drive those large locomotives if you need it. If you don't, you can use the onboard one. And 10 amps peak is actually pretty good size. There's a lot of my competitors that are only at 5 amps.
Yes.
So
you're correct.
Yep. And so that's actually not a bad size. I also build. This is somebody else's board, but not mine. But I also build a matching one that's the same exact 10 amps, same exact chip. And if you have two motors, you could drive one motor off of one board, the other off the other. If you have two locomotives, you could drive one locomotive off of one off the other. And now you've got 20 amps.
Wow, that's amazing.
And then we have an optional board that is actually, this is an interesting board because this one, you can hook this thing up to track power, AC, DC, or DCC without a battery. So that's a kind of an amazing little box. And then, of course, the standard would be with a battery, which is what we're running today.
Okay. All right. I'd like to thank you for showing us your Pro system, or PROSys today. And is this available now, or?
Check our website, scaledautomation.com, and I don't have this product on there right now, but we just finished the major development. It's ready to be produced. They'll be there shortly.
All right, sounds great. And thank you once again.
Thank you so much. It's been my pleasure.
Okay. Check out Scaled Automation. We'll see you guys later.